this is the IPS project. I'm Richard, and today I'm going to have a look at a split rail. Now I'm going to use an op-amp for the split rail. Apparently it should be quite simple. I had a quick look at the circuit, but let's start off with a diagram and then we'll move on to the actual circuit on the breadboard. So, quick diagram on the whiteboard here. It's very simple. It is literally just a buffer. All we're doing is creating a voltage divider on the non-inverting input, goes in, and output is tied round to the inverting input. Basic buffer. There's nothing more to it than that. Of course, if you have 12 volts, you just create an even voltage divider, so you get 6 volts in on your non-inverting input, and your output will be 6 volts. Now, your following circuit uses that output as its ground. Simple. What more can be to it than that? That just seems basic. On the circuit that I'm looking at, it's got a couple of extra resistors shoved in there. There's a 1K in there between the inverting and non-inverting inputs, and sorry about the crudity of the drawing, but I also have a 15K resistor up here, and I think those two resistors are there basically for stability reason. I think in case the load was to change slightly, or maybe the supply voltage was to change and you get a slight variation. I'm hoping that those two resistors are just there just for that reason of stability. Of course, you'd have capacitors, bypass capacitors on the rails just to help keep everything nice and smooth, but you know, basic stuff. So there you go. So anyway, let's have a look at it on the breadboard. So here we have the op-amp. It's the UA741. There is an LM741 as well, but there's other variations of it. Lots of people have done the 741 op-amp. This here is effectively my output, which is going to be my ground. So that's going to be my common point. So let's have some measurements of the voltages. So we'll start with the actual supply voltage, main voltage being, I suppose I ought to turn it on. It does help. Power on. And we have nearly 12 volts, not quite. I suppose a bit of loss in cables and stuff. But as this is going to be my common, let's see what I'm going to get if I have it from there. I have plus 5.8 volts and minus 5.97. So actually the minus side is more nearer to that 6 volts than I want, because it's half the supply voltage, which is brilliant. So I mean, if I look at that, if I can get onto pin 3 without shorting everything out, there you go. That's my input. So my input is my output, because it's a buffer. Simple. There you go. Can't get simpler than that, can you? And now I'm going to have a look at this other op-amp that I've got set up on here. Now this is the LM358, which I've used in other videos when I've been starting to look at op-amps. And the nice thing about the LM358 is that in a single rail supply, single voltage supply that you've got plus and ground, then this one will go down to ground for its output, which is very, very useful. But in this instance, it should work exactly like the 741. So let's turn that on. Let's look at the voltage across that. Still the same, 11 point. It's slightly less voltage. It's not very stable, this, because I've got this breadboard's a bit rubbish and they've got loads of wires. So over here is the common. This is the output for that, for at least one of the op-amps, because it's a dual op-amp package. So on the positive side, I've got that on the negative, on the common, sorry, I've got 5.9 volts, brilliant. And on the negative side, minus 5.94 volts. So yeah, it does exactly the same. That's brilliant. It doesn't matter what amp you use, it works as a buffer. You set your input to be half your supply, and your output as a buffer it'll be your input. Brilliant. So I'm just going to have a quick look at another circuit. Now, when I first started testing op amps to look at how they work, and I've no idea what I've done with it, there it is, I had this little circuit with an LED on it, so that as I turned up the input voltage, the non-inverted input would rise, but it didn't work very well with a UA741, because the UA741 op amp needs a negative rail for the voltage supply, and I didn't have that. So I used the LM358. As I explained, the LM358 doesn't need to have a split rail. It can work from a single rail and still go down to ground on the negatives, on the ground side. So let me just set this up, and we'll see that it will work with this split rail. So now I've set this little circuit up. I've basically got the 741 creating a split rail voltage supply, and then that is going to power this op amp. So I've got the positive there, the negative onto the negative there, so that's across the 12 volt rail, but my output from this signal, from this item, goes to the common, what would be what I'm calling the common rail, the output, so that the output is now able to swing between the positive 6 and the negative 6, even with this op amp working as a buffer. It sounds a bit convoluted because I'm using two op amps, but it does work. Let's turn it on, and then if I slowly turn this up, if I was using just straightforward one LM741 as my input for this to see how a buffer works from this circuit that I'd done before, then this LED wouldn't work properly, because the rail for the supply rail for this op amp was only ground and positive, where now it's effectively got ground and negative, with the output for the LED being the common, or the output of the split rail over here. So that means that this will now work with an LM741, UA741, whatever it is. I do actually have the LM358 over here, so let's see if I can just connect that in, keep everything in shot hopefully, and then turn it up, because I should have still the same. Yeah, there we go, still works, because the 741 that I've got here has got a split rail supply now. So this circuit that demonstrates it, the use of a buffer, still works just fine. Yeah, all seems to work just fine, as expected. So there you go, split rail op amp. Basically it's just a buffer. There's not much more to it than that, is there, really? I mean, what you put in is what you get out. So if you've got a 12 volt supply, use a voltage divider, gives you 6 volts on the non-inverting, you're going to get 6 volts out of the split rail. But then the following circuit, you use that output as your common, because as we know, op amps sink and source current through the output. It goes both ways, which is brilliant. So you just hook up the rest of your circuit with that being your common, the output being your common, and it all works. Thing is though, obviously if your following circuit requires 6 volts, then you're going to have to double that. You're going to need 12 volts for the split rail, and if it needs something like 12 volts, then you're going to have 24 volts for that split rail to work, because obviously you're using half that voltage. Of course, this might work better with op amp circuits, where the op amp requires you to have that positive and negative rail, like we've seen in the example on the breadboard that I did, and that works just fine. So yeah, there you go. It's just a buffer of sorts. It just depends how you use it. I'm going to do some more experimenting with it, especially looking at maybe a circuit that requires that negative side of the circuit. Should work just fine. There you go. What more can I say about it? Anyway, if you like this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.